All right, today we're going to trace the incredible story of an idea that literally jumped right off the pages of science fiction and onto desktops all around the world. We're talking about the history of 3D printing. But before we dive into all the history, let me just ask you something. What if you could print, well, anything you could imagine? Not just words on a page, I mean a real physical object. A tool, a toy, a replacement part for your bike, or what if you could print a human organ? I mean, that's the wild promise that has been driving this technology from the very, very beginning.
So let's get into it. Act 1. Our story doesn't start in some fancy high-tech lab. Nope. It begins in the world of pure imagination. We're going way back to a time when 3D printing was just a science fiction dream.
Believe it or not, as early as 1945, a sci-fi author named Murray Leinster was describing a machine that sounds just shockingly like a modern 3D printer. He imagined this constructor that could literally draw objects into existence out of thin air. Now, this wasn't science, not yet anyway. But man, it planted a powerful seed in the minds of future inventors. And you know what? That seed started to sprout. Other authors imagined similar devices. And then, in 1971, we see the very first patent for something called a liquid metal recorder. But the real breakthrough, that came in 1981. A researcher in Japan, Dr. Hideo Kodama, he patented a system that used UV light to harden resin, one layer at a time. It was the first real-world example of what we now call additive manufacturing, the whole process of building an object by adding material instead of cutting it away. Okay, so let's jump forward to Act 2, the pioneers of the 80s. This decade was absolutely pivotal. This is when a handful of brilliant inventors, all working on their own, finally turned that science fiction into straight-up science fact. And get this, here's a little piece of historical irony for you. It's kind of wild. In 1984, a team of French inventors actually filed a patent for 3D printing technology. But their company ditched it, saying there was a lack of business perspective. Yeah, just 3 weeks later, an American inventor filed his own patent for a process that was almost identical. Ouch. That American? His name was Charles Chuck Hull, and he is now pretty much known as the father of 3D printing. He didn't just patent stereolithography, or SLA, he also founded the very first 3D printing company, 3D Systems. The whole process is genius, really. You have this super precise UV laser drawing a shape on the surface of a liquid plastic resin, and it hardens instantly. Then the platform lowers just a tiny bit, and the laser draws the next layer right on top. Then, just a couple of years later, in 1986, a PhD student at the University of Texas named Carl Deckard came up with a completely different method, selective laser sintering, or SLS. So instead of liquid resin, SLS uses a bed of superfine powder. It could be plastic, metal, even ceramic. A powerful laser then zaps the powder, fusing the particles together to form a solid layer, and then a new layer of powder gets spread on top, and you do it all over again. All right, now for the third foundational technology, and this one has the best origin story. It's probably the one you're most familiar with today. In 1989, a guy named Scott Crump was trying to make a toy frog for his daughter using a hot glue gun. And he had this brilliant idea to automate the whole process. And just like that, fused deposition modeling, or FDM, was born. It's basically a really, really precise robotic hot glue gun that melts a plastic filament and draws with it, layer by layer, building an object from the ground up. So let's just recap for a second, because this is super important. By the end of the 1980s, these three totally distinct technologies had been invented. One used liquid resin cured by light, one used powder that was fused by a laser, and one used melted plastic filament. Together, these three became the absolute bedrock of the entire 3D printing industry. But, and this is a big but, there was one massive catch. While the technology was finally real, it was unbelievably expensive. We're talking over $300,000. These machines were huge, they were complex, and they were strictly locked away inside major corporations and research labs. The dream of printing anything was real, but for pretty much everyone, it was still out of reach. And that right there brings us to Act 3 and the 2000s, which was the moment everything changed. This is the part of the story where the power to create was finally, and I mean dramatically, put into the hands of the people. So what happened? What was the big bang that changed everything? Well, the answer is actually pretty simple. Key patents expired. When Scott Crump's patent for FDM officially entered the public domain in 2009, it was like a dam breaking. A total flood of innovation was unleashed as inventors everywhere were suddenly free to build on and improve the technology without any restrictions. Now, even before those patents expired, a movement was already bubbling up that just perfectly captured this new spirit. In 2005, Dr. Adrian Boer started something called the RepRap Project. It was an open-source initiative with a totally mind-blowing goal: to create a 3D printer that could print most of its own parts, a self-replicating machine. This project inspired a global community of makers, and it laid all the groundwork for the explosion of affordable desktop printers that came next. Okay, so the tech is finally affordable, it's accessible. A whole new question pops up. What are we actually going to build with it? Let's move to our final act, printing a new world, and see how this technology is fundamentally reshaping our lives today. And maybe nowhere has the impact been more just profound than in medicine. We've gone from printing scaffolds for lab-grown organs back in 1999 to printing entire custom prosthetic limbs and even prosthetic eyes. And today, scientists are on the absolute frontier of bioprinting, using living cells as ink to create bone, tissue, and one day, hopefully, fully functional transplantable organs on demand. The technology is also making things lighter, stronger, and way more efficient. In aerospace, companies are printing these incredibly complex jet engine parts that would be impossible to make any other way. In space, astronauts don't have to wait for a supply mission to get a new wrench. They can just print one. And back here on the ground, we've even seen entire car bodies printed out. And it just doesn't stop there. The applications just keep expanding. We have giant 3D printers now that are creating the walls of houses. The technology is also just naturally more sustainable. Traditional manufacturing is subtractive. It's like sculpting. You start with a big block and cut material away. But additive printing only adds material where it's needed, which creates almost no waste. And maybe most importantly, these printers are now in schools, empowering students to become the next generation of creators and inventors. I mean, when you put it side by side like this, the journey is just absolutely staggering. In just a few decades, we went from a machine that cost over $300,000 and took days to print one simple prototype to a device that can sit on your desk for a couple $100 and print almost anything you can imagine in just a matter of hours. And that brings us full circle, right back to that first question we asked. We started by just imagining we could print anything. Now, we've gone from printing plastic toys inspired by a glue gun to printing living human tissue. The science fiction dream is now a reality. So the only question left is, what will we print next?